Question 10, as it looks like it's going to be long, we are to use fundamental theorem of algebra to determine number and types of roots of polynomial equation. There are two different types of problem in this. The first type of problems are the easy ones. Let's use our calculators directly to solve them. Now, since this is degree 1, you can manually do it or you can type it in the calculator as it is. 5x plus 12 equals 0. You just have to press shift and solve. And this is the old saved answer. That's not the correct answer. Press equal to. This is the correct answer. You can see the answer is negative 2.4. But that may not be there in the option. So what you need to do is you need to solve this up. You can see negative 12 divided by 5 is negative 2.4 itself. So that's the correct answer. If it's quadratic, you just have to press mod 5, and this is 3, and type in the coefficients 1, minus 4, and 40. And here we go. The answers are over here. Did we type all the answers correctly? Yeah. Coefficients, yes, we have typed it correctly. It's 2 plus 6i, 2 minus 6i. They're conjugate always. So you can see 2 plus 6i and 2 minus 6i. This is similar to the question number 7. We have already done such problems. Even these were solved in the question number 7. Now we have x power 5 and 4x cubed. Now you can't take u substitution because it's not a multiple. See, 3 multiplied by 2 must be 6. Here we have 5. So we have to find other means. The other means are removing common term because there are only two terms. There is no third term and it's equated to 0, right? So you can do this, remove x power 3 common outside. What remains is x power 2 plus 4. That is equal to 0. So now you can equate this and this term to 0, right? So x cubed is equal to 0 or x squared plus 4 is equal to 0. Now we can solve each of them individually. So one answer obviously you will get degree 3, it's all 0. Because x cube is 0, that means take cube root on both these sides, it will be 0. Another one, we can use calculator. Since over here it's square and there is positive, it goes to the other side, becomes negative. We'll have imaginary answers. Let's do it over here. Mod 5 and 3 for quadratic. The coefficient is 1. And then there is no x term, it's 0. And lastly, we have 4. The answers are 2i minus 2i. So the answers over here is, say, 0. But the multiplicity is how much? Degree is 3, so it's multiplicity 3. And the other roots are 2i and minus 2i, you can see. Okay, they're asking you to write like this. It's very important to write like this then. You know the x cube is 0, right? What does this mean? X multiplied by x is all 0. So there are how many 0 roots? 1, 2, 3. So the solution will have x is equal to 0, x is equal to 0, x is equal to 0, and over here we got x is equal to plus or minus 2i, right? So we write all this 0, 0, 0, 2i. And they have also asked what type of roots. I forgot to tell this. Whenever there is I, it's called imaginary root, otherwise it's all real root. Number 0 is a real number, so it's 3 real roots and 2 imaginary roots. Now degree 5, you have to justify 5 roots over here. Let's look at other problems. Here, different ways can be used to solve this problem. What I usually prefer is, instead of x power 4, I take it as u square. Like, assume u to be x to the power 2. So what is u square? X power 4. We have done this in the question number 7. So here this is u square minus 625 equals 0. Now we can use the calculator and solve this, right? It's a quadratic. Again, we just use mod 5 and 3. The coefficient of x squared is u squared is 1. There is no u term. And lastly, we have minus 625. So what are the answers? It is 25 and minus 25. So here u is equal to 25. U is equal to minus 25. So what is u basically? It's x squared is equal to 25. X squared is equal to minus 25. Now, I don't need to use the calculator. If you want, you can do it. Again, this to the other side and this to the other side, it becomes a quadratic, x squared minus 25 or x squared plus 25. Here, just take the square root on both the sides. What happens? X is plus or minus 5. Square root on both the sides, plus or minus 5. Here, it becomes plus or minus, since negative is there, phi and I. imaginary number. So now what are these solutions? There are 4 roots. 2 are real, 2 are imaginary. That is the answer. You can see here that's the final answer. 5, you can write 5 plus or minus 5 first, and 5i minus 5i, 2 are real, 2 are imaginary. What about this problem? This is again direct. Do it in the calculator, mod phi 3, and you get the answer. And at the end, you need to select this. What are the roots? It's only one root. This is like, sorry, not one, this is 2. One root is 1 plus root 2 by 2, and one more is 1 minus root 2 by 2. But these are all real numbers, so both are real roots over here. Again, we can do this. Okay, now this one is little different. Here you can see there is x, and there are only 2 terms. So take x outside, so you will remain with 1, x is gone, x power 4 minus 81 equals 0. Now you can equate this, x is equal to 0, x power 4 minus 81 is equal to 0. Now how did we do x power 4 just a while ago? You assume u to be x squared, u squared is equal to x power 4. Only when it's possible when it's even numbers. Cube, it's a different method. Now here what you do is x power 4 becomes u squared, that is minus 81 is equal to 0. Now you can, instead of calculator, you can do it by yourself. U squared is equal to 81. Take the square root on both the sides, u becomes plus or minus 9. Now what is u? U is x squared. So x squared is equal to plus 9, x squared is equal to minus 9. Now again take the square root on both the sides. X becomes plus or minus 3, x becomes plus or minus 3i. Why is this I? Because it's negative over here. Now how many roots are there? 1, 2, 3, 4, 5. So 5 total roots, all done. 2 are imaginary, 3 plus or minus 3i are imaginary. 0 is 1 root, plus or minus 3 is other 2 roots, so 3 real roots. So this is the final answer. You can see here it is all are written in detail. 0 plus minus 3 plus minus 3i, so 3 real roots, 2 imaginary. This direct and calculator, you can do it by yourselves, very straightforward. This is it. Now here both are real roots, you get them in calculator directly. What about this over here? Again, it's the same thing. You do not need to use the formula or anything of quadratics. You can just basically use calculator, solve it up. So this is the answers. Now both are imaginary over here, 2 imaginary roots. Cube, again you can do it in calculator. Now here what happens is, if you put this in calculator, let me show it to you. It's by mod 5 and 4. The coefficient of x cube is 1, then there's 0, 0 and 1. Now what's the answers? Minus 1 is the first root. You can see half plus or minus root. This is the same thing. Over here they have written half separately, the by 2, or you can write it as a whole. And there are 2 imaginary, plus and minus. So 2 imaginary and 1 real. Here also you just calculate a mod phi 3, you get the answer. Both are imaginary. Again, straightforward problem. Please do them by yourselves. They're all similar, even over here, calculator. Now x power 4, I'm going to do this because it's power 4, right? Now assume u is equal to x squared, u squared will be x power 4. So I'm going to write 16 u squared minus 625 equals 0. And now let's use the calculator. Now it will be mod phi, and this is quadratic, so 3. Type in the coefficient of u squared is 16. There is no u, so it's 0, and lastly minus 625. So the answers are 25 by 4, or you can write 6.25 plus or minus. So you'll have only 2 answers. So u is equal to plus or minus 6.25. Now what happens? What is u? X squared basically is u. So x squared is 6.25 and x squared is also minus 6.25. Now you can either do it in this quadratic form itself. We just now put it. Now this will be 1, again 0, and this comes to the other side and becomes minus 6.25. The answer is 5 by 2 and negative 5 by 2. That's x is equal to plus or minus 2.5. And over here, what's going to happen? Because it's minus, it's going to be plus or minus 2.5 I imaginary. You can do it in the calculator as well. We'll just see. Same thing, 1, 0, and this will be positive 6.25. Here, this is the answer. Or you can also use the square root. Let's go to mode 1. Square root of 6.25. Here, you can't put negative sign. If it's negative, just understand there is an imaginary I must be added. That's it. 5 by 2 is 2.5. So this is how we can solve it. There are two imaginary and two real roots. All are negative 5 by 2, positive 5 by 2, plus or minus 5 by 2 I, 2 real, 2 imaginary. Again, similar, please do it by yourselves. And here are the answers. This one now, since there is x throughout, what I can do is I can remove the x common. See, x power 5 minus 8x cubed plus 16x is equal to 0, right? Take the x common out throughout. So what happens is x is gone. You will have x power 4 minus 8x squared plus 16 is equal to 0. Now this one has even powers. This can be written as quadratic. You can't directly solve it. You can't put this in calculator, or you can't just take again x squared because there's 16 here. So it can be equated as x is equal to 0, x power 4 minus 8x squared plus 16 is equal to 0. Assume x squared is equal to u. So it is u squared minus 8u plus 16 equals 0. Now we use the calculator and solve this quadratic. Mode 5 and 3. Over here it's 1 minus 8, 16. And what are the answers? It's 4. That's it. See, now over here you must be careful. What does this 4 mean? It's a repeated root. Let me just check the coefficients. Yes, 1, 8 minus 8, 16. That means it's like this. U is equal to 4, right? U minus 4 the whole square. It's a repeated root by twice. Okay, this is repeated twice, but no problem. What is u? X squared is equal to 4, right? So take the square root. So x will become plus or minus 2. That's it. But here you must understand there is a multiplicity of 2 for both of these. So there is plus 2 multiplicity 2, plus 2 plus 2. So x is plus or minus 2 means what? X is 2, x is minus 2. But we know over here this is having a multiplicity of 2. Instead of 2 roots, we only got 1. That means it's a repeated. U is equal to 2, u is equal, 4, and u is equal to 4. Okay, this is the situation. Now x squared, u squared means x squared is equal to 4. It's plus or minus 2. Basically, you're having plus 2, x is minus 2, minus 2. So that's it, minus 2, 2 times. Now you can see the final answer. All are real roots. 0, 2, 2, minus 2, minus 2. See here. Can you see that? It's just being repeated. Whatever you get, it's minus 2, minus 2, 0, 2, 2, 5 real roots. And this one over here, again, similar. What you need to do, you need to take the x term common out. We just now did it, right? The same concept, and you can get the answers over here. I'll just tell you how to simplify it. Take the x common out. You'll be remaining with x power 4 plus 2x squared plus 1 equals 0. Since over here it's not 0, it's 1. You can't directly solve it up. Left side is done. X is 0. But here you have to write it as u squared plus 2u plus 1 equals 0, and then simplify it out. So that's how we do this. And what about this over here? Direct calculator mode 5.4 will give you the answer. Oh, by the way, this is Descartes' rule. So now I will tell you how to do this Descartes' rule. Descartes was a, by his name you can tell is a French mathematician. All the weird, not weird names, like all these tough to pronounce names are generally French mathematicians. So what he found out is, just by the equation, just by little bit of rearranging the terms or looking at the signs, you can tell how many positive real or imaginary roots are possible, like estimate of it. You just need to count the sign changes. Let me write this. 3x cubed minus 4x squared minus 17x plus 6. This was plus. Now what is happening here? You can see it is plus, and to minus there is one sign change. I'll write 1. Okay, there is sign change. From minus to minus, no, there is no sign change. That's it. And again from minus to plus, second sign change, yes. You can write anything, yes, no. Say over here, yes and no is written. I just write tick and cross, it's fine. So two sign changes are there, right? That means for this original equation, two sign changes means there can be a maximum of two positive real zeros, not imaginary, real zeros. This is the first case. Now for the same equation over here, instead of x, not for the cube, instead of x you should put minus. Okay, this becomes minus. And then you need to change. I'll rewrite that equation. It's going to be 3. If it's odd power, minus will remain. You can try that in calculator by putting minus 1 cube. What is the answer? It's minus 1. Whereas minus 1 squared, it will be positive 1. So any even number powers, right, will make the sign positive because it's inside the bracket. So this is going to be x cube, but the sign minus will remain, so it becomes minus. Now what about this? It's squared, so this minus sign dissolves. It will just be whatever was there, 4x squared. Now here minus sign is there over here. There's no power, so it will be multiplied with this minus and becomes plus 17x. And lastly, we have plus 6. Now let me check the sign changes over here. This is for negative, not positive. This is plus, right? Positive. Now we are doing for the negative real zeros. Here from minus to minus, no sign change. Plus, minus to plus, yes, there is one sign change. And plus to plus, no sign change. So over here we can tell there is only one negative real zero. It can't be more. So this is how we found out. And now we have to make a table. I'll just show you the table. See, we found out how much only... Wait a minute. Now here this is wrong. See, you just have one sign change. Okay, this is no, this is yes, this is no again. Okay, this is error. I apologize for that. See, you can see it's only one sign change. There's only one negative real zero. Now to find the imaginary zeros, you must write the positive real zero, negative real zero, and imaginary as a table. The total cannot exceed the maximum degree. What is the maximum degree? It's power 3, right? So the total, no matter what, must be 3. It can't be more than 3. Here, positive real 0 are 2. Why? Because we got it over there. Negative real 0 is 1. So if 2 and 1 over here, then it's 0. But this is maximum we are talking about. But imaginary numbers can be in pair of conjugates, right? It comes in pairs. That means 2 can be over here. Can you subtract over here 2? If it's odd number, you just leave. If it's less than 2, you just leave it as 1 only. This you deduct. Make it 0. Because you are putting imaginary 2, somewhere you must deduct 2. Only this is possible to deduct. And now again it's 3. So these might be the possibility. So there can be either 0 or 2 imaginary. There can be only one negative root and 2 or 0 positive root. That is the answer. So this is for... this is actually for the positive real zeros, 2 or 0. Negative is only 1. Imaginary is 2 or 0 again. Let's do this one as well. Let me do one more little bigger problem. Over here the worked out solution is there. Similar. Cube means 3. Just easy. Let us even, this is power 3. You can see same thing again. All the steps are worked out. Make sure you look at this. If there is any error, I'm seeing some error. There is sign change, yes. Yes, okay, yes, oh, it's correct. Okay, there is no. So yeah, this is correct. All the sign changes are correct. Again, it's cubed itself. So let me just solve this anyways. So first thing is just check at the sign change. It's plus, right? 1, 2, 3. All are there. Positive, negative, negative, positive, positive, negative. That's it. So 3 sign changes. So how many positive real roots can be there? 3 positive real roots. Now what next? Change them like this. Put minus x inside x. And over here minus, again minus x the whole square plus 4 times minus x minus 6. Now solve them up. If it's odd power, negative sign remains. If it's even power, it goes off. So it'll just be minus x squared minus 4x minus 6. And now what you do is count the sign changes. No, no, no. So 0 negative roots. So the table I'll write over here positive, negative, and imaginary. And over here it's total, right? It can be 3, 0. This must be 0 because total must be 3. Now what happens is this is again 0. There can't be, you can't add them. This is the maximum number you find out over here. This is the negative real zeros, right? So over here it can be 1, over here 2, and over here 3 only, right? So the positive real zeros can be 3, 1, negative is only 0, and imaginary is 2 or 0. So that is the final answer. You can see here 3 or 1, yes, 0, 2 or 0 or 0 or 2. Generally, over here, the answers will be written as the higher number, the bigger number, and then the smaller number. So similarly, okay, now we got power 4, but it's just the same thing, guys. Over here, see the sign changes, no, no, no. Only one is yes. So there's one sign change. Over here, after changing the power, over here, if you put minus x to the power 4, it becomes positive only. This is power 2 itself, it will be positive. This one changes sign. So no, no, this is yes. Can you see this is yes? And again, no, only one sign change. Then all are imaginary. So this is the table over here. Now over here, it is not, let me just check. Yes, absolutely, this is correct. Now, what is the problem here? Your maximum positive real zero is 1, negative real zero is 1, imaginary is 2. Can you make imaginary 0? No, these can't be reduced, right? You can't make it 0, it must be 4. So there is no way you can reduce it. If it is 1, 1, that's it. No other changes. So this is the only possibility. Only when there is more than 2 over here, you can reduce it by 2 and then balance it out with imaginary. Similarly, please go through all these problems. The worked out solutions are there. Look at all the answers for yourselves. Solve it by yourself and then check over here. Even over here, they're all solved out. This is also simple cubic. The same method, it's just repetitive. Just be careful over here. Again, another one. Power 5, but still the same method. No changes in this. Again, power 4 problems. Because they are simple, you know. There's nothing much in this. Power 6 over here. But it doesn't matter how much is the degree. It depends on the terms. See, there are only 4 terms. So there is one sign change, no, no, 1. So there's 2 possible zeros over here. Yes, sign change, no, no, yes. Again 2. So 2, 2, and since it's degree 6, there must be total 6. So remaining must be added by the imaginary. So there is 2 imaginary, 2 real, 2 negative, real and positive. Now what we need to do is, we should reduce one of this. You can either reduce positive or negative, one by one. So where negative is reduced, add to the imaginary part. Because we can't add over here. Positive and negative maximum is 2. This becomes 4. Now what you can do is you can change this positive to 0, right? So okay, negative will be 2 and this will be 4. Last possibility is both will be 0 and 0 and this is 6. That is also possible. So this is how we can get all these answers. That's the answer. Over here again, similar problem. Please check it out by yourselves and then compare the answers. And that's the end of this topic. It was another lengthy one, but it's an easy one, I can say. Just a little bit of work. You can't directly jump to the answer in the last part. You have to do the sign change. You have to look at the table. Only then you can solve this.